Hey friends, I'm back with another cool topic, expanding on my GraphRag video, where we dove into AI recommendations. That was a blast, wasn't it? Today we're taking it up a notch by exploring the general applications of GraphRag, and we're also throwing in two other exciting concepts, light RAG and vector graph. These are like the superheroes of AI-driven data retrieval, each with unique powers that make them game changers in how we interact with information. Imagine you're trying to solve a massive puzzle, whether it's finding the perfect book recommendation, uncovering hidden financial fraud, or even helping a doctor diagnose a rare condition. These tools are like your trusty sidekicks, helping you piece it all together faster and smarter. I'll break them down in a way that's super easy to grasp, and we'll explore how they're making waves in India and beyond with relatable examples. So grab a cup of chai, settle in, and let's embark on this AI adventure together. Let's kick things off with GraphRag, which stands for Graph Retrieval Augmented Generation. Picture this, you're in a bustling library in Mumbai searching for a book on Indian history. A regular search might give you a list of books based on keywords, but what if you want to know how the Mughal Empire connects to the Maratha rebellion or how trade routes influenced both? That's where GraphRag shines. Unlike traditional AI that relies on simple keyword matching or vector-based searches, which we'll get to later, GraphRag uses a knowledge graph, a kind of digital map where ideas, people, places, and events are nodes connected by relationships, like threads in a giant tapestry. It's like having a super smart librarian who doesn't just find books but also explains how everything is interconnected, giving you a richer, more context-aware answer. So how does GraphRag work? Imagine you're asking an AI, how did the Indian independence movement influence global politics? A regular AI might pull up random articles on Gandhi or the British Raj, but GraphRag builds a network of related concepts. Gandhi, non-violence, the Salt March, global decolonization movements, and even figures like Martin Luther King Jr., who drew inspiration from India. It uses a graph database to store these connections as nodes, like Gandhi or Salt March, and edges like inspired or led to. When you ask a question, GraphRag doesn't just fetch isolated bits of text. It navigates this web of relationships to pull together a comprehensive answer. For example, it might tell you how the Salt March sparked global interest in civil disobedience, linking it to anti-colonial struggles in Africa. This ability to perform multi-hop reasoning, connecting multiple pieces of information through relationships, makes GraphRag incredibly powerful for complex queries. Now let's talk about its applications in India. In healthcare, GraphRag is a game changer. Imagine a doctor in a rural clinic in Rajasthan trying to diagnose a patient with unusual symptoms. Instead of sifting through endless medical journals, GraphRag can analyze a knowledge graph of diseases, symptoms, treatments, and patient histories. It might connect a rare fever to a specific malaria strain prevalent in certain Indian regions, cross-reference it with recent outbreaks in Rajasthan, and suggest tailored treatments based on local data. This is already happening with platforms like MedGraphRag, which organizes medical data into layers, patient records, recent studies, and medical dictionaries to provide precise, evidence-based recommendations. In a country like India, where healthcare access varies widely, GraphRag could empower doctors in remote areas to make informed decisions, potentially saving lives. Another exciting use case is in education. India's education system is vast, with millions of students and diverse syllabi. Imagine an AI-powered learning platform for CBSE students preparing for board exams. GraphRag could map out connections between topics, say linking Newton's laws in physics to real-world applications like ISRO's satellite launches. A student in Delhi asking, how do Newton's laws apply to rockets, could get an answer that not only explains the physics but also ties it to India's Chandrayaan missions, making learning engaging and relevant. This context-aware approach ensures students don't just memorize facts but understand how concepts interrelate, fostering deeper learning. In the financial sector, GraphRag is a superhero for fraud detection. India's digital payment boom, with platforms like UPI handling billions of transactions, has also attracted fraudsters. GraphRag can map relationships between transactions, accounts, and user behaviors. For instance, if a suspicious transaction originates from a new account in Bengaluru, GraphRag could trace its links to other accounts, locations, or even devices used in past frauds. By spotting these hidden patterns, it helps banks like SBI or fintechs like Paytm catch fraud faster than traditional systems, which might only flag individual transactions without seeing the bigger picture. This relational approach is like having a detective who sees the entire crime network, not just one clue. Let's pivot to light RAG, which is like GraphRag's nimble, cost-effective cousin. While GraphRag is powerful, it can be computationally heavy, like driving a bulldozer through a narrow alley. Light RAG, developed as an alternative, combines the best of graph-based reasoning with the speed of vector-based retrieval, making it faster and cheaper without sacrificing too much accuracy. Think of it as a sleek scooter zipping through Bengaluru's traffic, efficient and agile. Light RAG uses a dual-level retrieval system. Low-level retrieval grabs specific details, like names or dates, while high-level retrieval captures broader themes, like trends or concepts. It also employs a deduplication process to avoid redundant data, making it leaner than GraphRag, which might generate thousands of community reports for a single query. How does Light RAG work in practice? It starts by breaking down documents into chunks, extracting entities and relationships to build a knowledge graph, much like GraphRag. But instead of trawling through massive graph communities, Light RAG uses vector embeddings, numerical representations of text, to quickly find relevant nodes and their neighbors. For example, if you're analyzing a legal case in an Indian court, Light RAG might extract entities like defendant, plaintiff, and precedent from case documents, then use vector search to find similar cases while cross-referencing the graph for contextual links, like how a 2023 Supreme Court ruling connects to older laws. This hybrid approach reduces the number of API calls and token usage, making it cost-effective for businesses. In India, Light RAG could revolutionize legal research. Imagine a lawyer in Chennai preparing for a property dispute case. India's legal system is complex, with thousands of precedents and statutes. Light RAG can quickly pull up relevant case laws via vector search, and then use its graph to show how those cases connect to current property laws or historical rulings in Tamil Nadu. This saves hours of manual research, which is critical in a country where legal backlogs are massive, over 40 million pending cases, according to recent data. By streamlining research, Light RAG could help lawyers build stronger cases faster, easing the burden on India's courts. Another cool application is in agriculture, a backbone of India's economy. Farmers in Punjab often face challenges like unpredictable weather or pest outbreaks. Light RAG could power an AI assistant that analyzes data from government reports, weather forecasts, and local farming practices. For instance, if a farmer asks, "What crops should I plant during a dry monsoon?" Light RAG could retrieve specific data on drought-resistant crops like millets, then use its graph to link those crops to successful case studies in Punjab, soil types, and market prices in Chandigarh. This context-rich advice could help farmers make informed decisions, boosting yields and livelihoods in a sector that employs nearly 50% of India's workforce. Customer support is another area where Light RAG shines. Take an Indian e-commerce giant like Flipkart. Customers often have queries ranging from simple, "Where's my order?" to complex, "Why was my refund rejected?" Light RAG can quickly fetch general troubleshooting guides using vector search, then refine answers by analyzing relationships between customer profiles, order histories, and company policies. For example, if a customer in Hyderabad complains about a delayed delivery, Light RAG could check the order's logistics trail, see if the delay is linked to a regional warehouse issue, and suggest a resolution based on Flipkart's refund policies. This personalized fast response improves customer satisfaction in a market where e-commerce is booming. India's online retail is expected to hit $200 billion by 2027. Now let's dive into vector graph, which is a bit of a hybrid concept, blending vector databases with graph-like structures. Think of it as a middle ground between the simplicity of vector-based systems and the relational depth of knowledge graphs. Vector databases store data as numerical embeddings, like coordinates in a high-dimensional space, making it super fast to find similar items based on meaning, not just keywords. For example, searching spicy Indian food might pull up recipes for biryani and vindaloo because their embeddings are close in meaning. Vector graph takes this a step further by adding lightweight graph structures, allowing some relational reasoning without the heavy lifting of a full knowledge graph. In simpler terms, vector graph is like a supercharged Google search tailored for specific domains. It uses vector embeddings for speed and scalability, but it also maintains a basic network of relationships. For instance, in a movie recommendation system for a platform like Netflix India, vector graph could store movie descriptions as vectors to find films similar to RRR, based on themes like action or historical drama. Then it could use a simple graph to link RRR to related entities like S.S. Rajamouli, the director, Telugu cinema, or Indian epics, suggesting other films like Bahubali or even regional hits like Kantara. This balance of speed and context makes vector graph ideal for applications where you need quick results but also some relational insight. In India, vector graph could transform e-commerce recommendation systems. Imagine shopping on Amazon India for a Diwali gift. A vector graph system could use vector search to find products similar to brass diya, like candles or lanterns, then use its graph to suggest related items like rangoli stencils or sweets gift box based on cultural connections to Diwali. This creates a more personalized shopping experience, which is crucial in a market where 70% of consumers prefer tailored recommendations according to recent surveys. Unlike GraphRag, which might overanalyze every connection, vector graph keeps things light and fast, perfect for real-time applications. Another exciting use case is in social media analysis. India has over 500 million social media users, with platforms like Instagram and X buzzing with trends. A vector graph system could analyze posts about a new Bollywood movie, using vector embeddings to group similar sentiments, like loved the songs or amazing action. Then it could use a graph to link these sentiments to influencers, hashtags or locations, like Mumbai or Delhi, helping marketers understand how the movie is trending across India. For instance, if hashtag Pathan 2 is trending in Kolkata, vector graph could suggest targeting ads to Bengali-speaking audiences, boosting engagement for film studios. In journalism, vector graph could help Indian newsrooms like The Hindu or NDTV tackle misinformation. With fake news spreading faster than a Delhi metro at rush hour, vector graph can analyze articles or social media posts by converting them into vectors to find similar stories. Then use a graph to trace their sources or connections to known misinformation networks. For example, if a viral post claims a new COVID variant is spreading in Kerala, vector graph could verify it against credible health reports and flag inconsistencies, helping journalists fact-check in real time. This is vital in India, where misinformation can sway public opinion during elections or health crises. Comparing these three, GraphRag is the heavyweight champion for complex relationship-driven queries, like academic research or fraud detection, but it's resource-intensive. LightRag is the agile all-rounder, blending speed and context for applications like legal research or agriculture. Vector graph is the sprinter, perfect for fast, scalable tasks like recommendations or social media analysis, with just enough relational depth to stay relevant. In India, where digital adoption is skyrocketing, 1.2 billion mobile users and counting, these tools are unlocking new possibilities. GraphRag could power ISRO's data analysis for satellite missions, linking telemetry data to weather patterns. LightRag could help startups like Krishi Network advise farmers in Hindi or Tamil. Vector graph could drive Zomato's restaurant recommendations, connecting spicy street food to local vendors in Delhi's Chandni Chowk. Each tool has its sweet spot. GraphRag is ideal for high-stakes domains like healthcare or finance, where precision matters. LightRag suits budget-conscious businesses needing quick, context-aware solutions, like India's growing startup ecosystem. Vector graph excels in consumer-facing apps where speed and personalization are key, like e-commerce or entertainment. Together, they're transforming how India leverages AI, from empowering rural farmers to catching urban fraudsters. So next time you're navigating a complex problem, whether it's choosing a movie or solving a crime, remember these AI superheroes are working behind the scenes, making sense of the world's chaos, one connection at a time. Stay curious, friends, and I'll catch you in the next video.